Hello, and in this part we're going to combine the screens and the fuel tank in one piece. So what I will be building is, if I, for example, take this box, I want to define an area or a space where I would like to have my tank fuel and a screen. So we'll be using a box to define this area, and then I will be deciding where the pieces should be placed. So here I have a box, and I'm going to make sure that my box is big enough to at least fit one of these tanks. So I would be able to see it later on. Now from this box, I would like to ask the bounds. And the reason why I'm asking the bounds is because the bounds is quite consistent with the placement of the primitives. So primitive 0 will always be in this axis, 1 there and 5 there. What I would like to have here is also a null node, so I can reference this size. So out size, so this will be the size. Then here I would like to blast away a few primitives, and I'm going to click on this icon to make a selection, and I will be selecting these 3 primitives, so the top one and the back one, and press enter to confirm, and now they are gone. So I place a bevel on here, and then we can bevel these edges, as you can see. To give this a thickness, I'm going to use the extrude node, and then I can give this a thickness. And I'm also going to enable the output back. So what I'm going to make is, I have a boolean here, and I want to boolean out certain pieces. So with this boolean, I want to boolean out a specific area. This will be the metal part around my tank. So I want to boolean a certain distance from this panel, and we can actually use a bounds here again. And in the bounds node, we can sort of like play around with these values on how far they are going. So in here, what if we go minus? You can see that we are here getting these spaces. So we here go minus. And also I want to make sure it's going towards this. So we have this shape then. Then this could also be beveled. So here we're going to put a small bevel, and now we have this nice round bevel there. But here I want on this support frame my screen also be attached. So if I here have my screen, I can also put a null node here, and this is then out screen, and I can reference this here with an object merge node. I can search for the screen, and now I have the screen. So I see that my direction of the screen should be like this. Then we can, for example, say, what if my screen is around here? Then I would like to also have this sort of these support frames also coming here to the screen, so it's attached in there. What you could do is, for example, fuse all the points together here. So if you also disable remove repeated vertices, this will result in one point. And on this point, I will copy a box. So copy 2 points. And I will also copy a box on that point. And I will scale the box in such a way that I want to decide here on this placement there should be a support. So if I boolean this here in the bounds, we should subtract it and fill it here in further. Then we should see this support part now. I will put the transform also here to tweak the position. So as we can see, if we merge this together, the screen has now a support part. So if I go back to this transform where I decided the height, and if I would play around with this value, we can see that it's following perfectly. What could also be nice to have is to close one of these parts. So if I also quickly would reference my tank here, just for demonstration. So I referenced my tank here for demonstration at the moment. Let's say I want to close the bottom part here, that we don't see what's going on there. Then I can use this box here, and if I manipulate it in such a way, then I can basically close this section. So one of the possibilities is that we switch between different types of boxes. So the first here on 0 will be open, then the second one will be closing the bottom part, then I will just do this. And then for the third input, I will be extruding this upwards. So based on what the switch node is doing, we can then cover certain parts where we would like that. Then I would like to align this result a bit better, and I will be moving some of what I'm doing here a bit lower. And with this axis align, I'm gonna fill in first no change in everything. So what I would like to do here is I would like to align the front part with 0. In my case it's the z-axis, and I will be using the -1. And now even if the size got bigger, it still aligns perfectly. So this makes it a little bit easier to then place my screen and my tank props. Then here the next thing I would like to do is add some more details here on these sides. So we can start again by asking the bounds here of this object. And I would also like to know the bounds of these objects. And I'm gonna loop with each connected piece. So this will loop 2 times because there are 2 closed pieces here. And if I add the bounds of them, I then have nicely these 2 pieces, the bounds of these 2 pieces. Then I would like to boolean these 2 shapes with each other. So this one with this one. So then we boolean these shapes together, and I'm going to subtract again. But I'm not really happy with the result I'm having. I want to have specifically the lines at the top, in the middle, and at the bottom. So I can play around here with the padding distance, and as you can see, we can then get very specific regions now. So the idea is now that I use these points to copy a model on, and that model will then be booleaned on the sides here, so we have some side variation in there. Then I want to use a quick group here to extract certain parts, and here I'm interested in the top and the bottom, so top, bottom, and split geometry. So the reason why I split them, if I now put a normal node, I have now very specific normals. So if I put this to point normal and view the normals, we can see that they are now facing up and facing down based on their primitive. Then I would like to use a group, and in this group we're going to use an expression, and I will be using points, and I'm going to say add points dot z-axis if they are smaller than 0.1, then they will be selected. So that means all these points in the front are now selected. Then in the copy to points, I will be copying these boxes on the points, and then I will also fill in here the group, which is called group 2 in my case. These boxes are now being copied on them. So these might be too big in scale, and I can tweak them like this. Then I would boolean this result with my original here, and then I will subtract this again, subtract, and I can see I have to adjust my shapes a bit. Then you can start boolean out based on what you like to see. So as you can see, we have created the system to get these details. And you can also do a bevel here if you would prefer a beveling on that. And then we can bevel these parts out. So this is sort of the result that I was looking for, to get some variation in the shape so it's not consistent. Then next, what we could be doing is we could use the Sci-fi surface detailing. So first of all, I want to make a group selection on where I would like to have the detail. So in this case, the Z minus axis, and I'm going to use the Sci-fi surface detail, and I'm going to go for style 2 again. So now we have this detail on the model, and it looks like this. Then I'm going to fix the screen. So either you go back here to this transform and place it in the correct position, or you could also place down a axis align here as well. But in this case, by just changing some values in the transform, I can see it working. Then I'm going to focus on placing these tanks. So I want to create a system that automatically decides how many tanks are in the space. So I'm going to create a frame around this. So this is the frame model. Now I'm going to calculate how many tanks we're going to place. And I will be making some space, and I will be calculating underneath it here. And I will be using a duplicate. What I'll be doing first here in the duplicate is make sure that my models automatically are copied nicely next to each other. So I will be asking the bounding box of the current object. So if you type 0, it will look into itself, and then d.x size. And now they are perfectly placed next to each other. So if you increase this, they are now next to each other. Even if this model should have a different size, they are next to each other now. Then in here I want to control the total number by bounding boxes. And first of all, I would like to ask the bounding box of my size node. So we call this one out size. Then I would like to know the d x size in my case. And I want to divide this by my current size. So 0 means looking at the input of the node, and then I will also ask the x size. And now we can see we have a system that controls how much fuel tanks are placed based on the x size. And I would also like to do the same then for the y here, in case we have a long version. So I'm going to copy paste this node, and instead of filling in the x size, I want to fill in then the y size. So I'm going to copy this here, place it in the y axis, and also fill in here the y size. Then also same here as well, switching out the x with the y, and that should work. As you could see, they're all now placed based on how much space they could have in here. Now I would like to have this nicely fit into the center here, and one nice way of doing this is by using a match node, match size node, and by default it's gonna center this to the grid. So as you can see, it's now perfectly centered. I would like that the tanks follow the shape that I'm using as my reference. So I'm going to use an object merge node, reference my out size, and this can be used in the input here. And you automatically saw it already, that it jumped into the space. So it's going to automatically look for the correct spacing. What's also very interesting here is that we can scale to fit. So it's going to scale perfectly in this grid. And I don't need the Z size actually here. As you could see that my tank otherwise is getting squeezed. But I want to like the original Z size in my case. So if I now would go back here to my box, and if I would start scaling it, it's now perfectly following my original shape. I can see that it's perfectly aligned in my box. You can also see that the scaling might be a little bit off. If that worries you, you can also use the uniform scale option, so it stays consistent with the scale. And then you can also specify on which axis it should follow the scale. So in my case, the x-axis should be the scale to follow. So if I would look at here at the x-axis, we can see that it's perfectly stopping here at that point. So that could be interesting also to use, put my model to the minimum range. And then I can also place a transform here. Just in case I would like to tweak certain values, I can always go here in a transform node and tweak values. Now this is a new output, and I'm gonna use a null node here and call out and tanks and copy it. So I clearly know that these are multiple ones. And then in here I would like to replace the tanks with my tanks copied, so we have the result here of all the tanks. And then we can also tweak the position here with the transform. If we would like to have it further or closer or more up, we can then use the transform. Next thing I want to do is to create an inside model here to place behind the tanks and also cover the bottom and the top. So to do that, I will be going back here where I have created this original shape. Something also interesting here what we could do is adding a transform. And in this transform we can manually select the backside here and we can drag it away. We can sort of control how far the inside will be. From this part I'm going to make a group, and I would like to use this part as a group and call it backside. So just call it the backside, so I know this is the back, and I want to delete based on the backside. So in here, backside, and I only want to keep this primitive. Then I want to merge this blast node with the bevel, so we get this shape. So we have the shape with the bevel and also the backside here as well. So I will be fusing then this together. Then I will be polyfilling the result, and I'll be using single polygon, and we can also save this in a group. So in here at the blast node, what we can do is that we can blast away the backside and the patch, which is the polygon fill node. And if you reverse the selection, now I have this shape as result. So I want specifically this shape as result. So if I now would reverse this, I can now use this in the back. So null nodes, cutting this out, the back, and here I'm gonna reference this also with an object merge node and fill in out back. We have these primitives here. The only thing I noticed is I didn't align this part, so I can also in here add the axis align, and I took the Z minus, and the other ones I'm not going to change. So now it's perfectly the same space. So with this transform here node here, I can control how far we should place, or how far we should see in this container. Then I'm gonna add some supports and detail in this frame. So at the bottom and at the top here, I'm gonna add some sci-fi support pieces. And first of all, let's model that piece, and I'm gonna start with a box, and I'm gonna scale it something like this. I will be selecting these points and scaling them down. Then I will boolean other boxes in the shape. So I will be boxing and then subtracting from each other. Then we can define what it should look like. So for example, we can do something like this. We can take another box, merge it. So we can, for example, have something like this. Doesn't have to be the same. Then I'm gonna bevel some edges. So you could bevel everything if you want that, or you can go in here and select specific edges. So this is not procedural to do, but this model doesn't have to be fully procedural. Then in here, I'm gonna use another box, and I'm gonna place it somewhere here. Something like this, and then bevel the result as well, and then merge these results. So I have a shape that looks like this. Maybe one more detail, something at the bottom here, and I can do a similar thing again where I just use a simple shape like this box, place it down here, then using the edit to adjust the size a bit, to adjust the shape a bit. Then I can, for example, bevel this edge. Something like this, and then maybe I also want to have this side edges beveled like that. So this is then my model, and I will be using a transform, and I will put these models together like this or this, doesn't matter, just to have some like sci-fi agreeable, let's say. So I put them together like this, and at the bottom here I will also align this model here, and I would like to copy this model along the length of this box as well. So we'll be using object merge, ask the size, and I would like to extract the bottom primitive with the quick groups, and I can here select bottom and split geometry, so I have only the bottom. Then I will use a transform with the centers filled in, so here with the centroids filled in, and I will scale this then in 0. So basically we have just a line at the moment. And we're also using a fuse and disable the remove repeated vertices. And I can also resample this line, so we have multiple points. I can in here decide how much points I have, and basically we're going to use these points to then copy our models on. So copy 2 points, and we're going to copy that model on these points. As you can see here, we might need to disable the transform using our point orientation, so it ignores that, and then I will transform this piece here and rotate this in the right direction. So they are now placed next to each other. What could be nice to have in this case is that we sort of have a symmetry going on. So we can see that all the models are sort of like copied in the same direction. And what I could be doing here, so I can cut this piece into two smaller pieces. So if I now do the copy to points, we have then this side, and I can now mirror it back, as you can see here. Then if I look at my original shape, they are not really following the cube. We can also use the group range node here, and we can in the group range search on group type points, and when you can say that, for example, this point, so in my case it's the first point, so point 0, there should not be a model copied. So we can use this group here, and now we can see that the model is not copied in there. Now we could also use the match size, like I mentioned, and then we can use this node. I can copy that here. I'm not really interested in these ones, so I'm gonna put none in everyone, so it's automatically also placed on the bottom. You could also use this Y size to automatically place it on the top or at the bottom if it's not correctly placed. Then here again we want to scale to fit, and I'm not interested in the Y-axis or in the Z-axis, only in the X-axis. Now I'm gonna again use the transform with center, and we can create some more variation. Then I can use a null node here and then call this out support and put it here as well, calling this out support, and let's see if they are placed correctly. And you can see them here. They also should have a normal. So in here I'm going to place a normal node. So they have normal, and they might be rotated in the wrong direction. So we can actually rotate this model right here, and I might have to tweak this also back. And let's see how they are doing now. So now they are placed better. So you can also tweak again with a transform so that they are, for example, are in the cage, because right now they are coming out, but that could also be cool to have. And we can also then have them at the top part. So what we could say is, if you want to have them at the top, we could simply rotate them, and we can use the match size node here again. And we are only actually interested in here using the maximum value, and then merge this together. And also place a transform with a center filled in here, and we can then tweak the position where we would like to have them. So if you want them more in the back, like this, that could also be nice to have. One thing I forgot to mention is, let's say here that if we want to have our fuel tanks being rotated 90 degrees, we can actually simply do that by using the transform here and start rotating here my fuel tank. And automatically the system is gonna find out what's the best position. So I will be using a switch here, and this switch will then choose between a horizontal or vertical tank. So based on what you would like to see, it's automatically being placed in. One more small thing we can also do here at the support system is that based on the scale, I can place more or less of these support structures. So if I scale them like this, we can create some cool shapes, but they are always 6 at the top, 6 at the bottom. So what I will be doing is I want to reference the size, so copy parameter, and I want to reference it to my resampling amount. So in here I would like to paste out this reference, and I want to multiply this in the resampling. So if I now scale, we can see that they're now automatically added way more of these details based on my scale. So if you want to have some extreme support pieces, they are now less than if you have some multiple of them. So that's a cool thing to already put in place right now. So, and that was it for this video. Next video we're going to create a digital asset from this tool, and then we can also test this out in Unity as well.